So I'm going to introduce myself in the meanwhile. I'm Pierre Krieger. I work for Parity technology, core engineer. I've been working for 2 years with my team on the Light client. And this presentation is going to introduce you to the concept of Light clients, and specifically browser-embedded Light clients, so a Light client embedded in a browser. This is going to be a very high-level overview, nothing too technical, but I hope it's going to interest you. And oh, cool. Okay, so as I said, I'm Pierre Krieger, and I'm going to introduce you to Light clients. So in order to understand what a Light client is, and especially why you should care, this is how a traditional Web 2 service works. You have end users trying to use a service like Facebook, Google, whatever, your favorite airline booking a ticket. They connect to a server that is owned by the corporation, and they just use the service. And this is the model that the web is based on currently, most of it, and we're trying to switch out of it. This is the Web 3 vision that we would like to pursue. So you can see the white markers that are labeled validators. These are really validators and full nodes. And all these white dots are spread around the world, all responsible for maintaining services, making things work. It's basically the infrastructure of a chain. And end users represented as these little red dots connect to these validator and full nodes in order to use the service. However, this is not how it works today, unfortunately. In practice, all the end users are in reality connected to a central access point that we call a JSON RPC node. And this is not great. This slide is the same as the previous one, but shown a bit differently. So you have a blockchain network, in reality, really split in two. On one hand, the validators and full node, which are really the chain itself. They are like peer-to-peer talking to each other, decentralized all over the world, and they're responsible for the maintenance of a chain. But accessing these full nodes is very not very technically difficult, but it requires some technical knowledge that the general public cannot do, basically. And on the other hand, you have end users, which just want a mobile app to access a service. They don't care what a node is. They don't understand what the Light client is. They just want to browse a website and access a Web3 service. And right now, the way it works is these two things, these two isolated networks, talk to each other through JSON RPC nodes. And I want to highlight that this is not a problem specific to Polkadot. This is really a problem that is widespread around the entire blockchain ecosystem nowadays. And we're fixing it. So why is this way? The reason is quite simple. It's just a technical issue. Just a technical issue. It took us 2 years to fix that, so it's not just a technical issue. It is a technical problem. Simply, the end users and validator nodes cannot talk to each other. So the central access point is a translator. And the consequence of this is that the end users, the software running on the machines of the end users, needs to blindly trust what this translator is saying. The translator translates a validator language, if you want. This is very high-level validator language into information displayed on screen. But the end user, the software running on the end user machine, doesn't know if the information is correct. It just assumes it is. So why does this need fixing? This is an important question. First of all, the central access point, as I just explained, is trusted. The end user, the software running on the end user machine, just assumes that everything is correct. But what if the central access point is hijacked? What if an attacker takes control of it? The attacker can just display whatever they want on everyone's screen, and this is obviously not great. You can just do phishing attacks on everyone. Even if you assume that it's not possible to hijack this JSON RPC node, there's still a question of reliability. We're trying to make applications that are very reliable. And having everything go through a central server, which could go down at any point, is not great for this. We want really something more robust than something relying on just a single server. And third, there's this front-runner issue. Since the JSON RPC node, the central access point, knows everything that the end users are seeing and submitting as transactions, they can just put their own transaction in front in order to gain profit from it. And we kind of want to avoid that. So this would also fix this problem. And the way we're fixing that is the name of the talk, Browser Embedded Light Client. So what does this mean? It's just, so a light client is just a different thing running on the end user machine. The software running on the end user that displays what's on the chain, instead of connecting to this central access point, connects directly to the validators and the full nodes, the infrastructure, instead of going through the central access point. So it was really just fixing the impossibility for them to talk to each other. Once they can talk to each other, we get rid of the access point, and everyone's happy. And in order to explain even more, it's going to be a bit difficult because I cannot see this, but I'm going to show you a small demo to illustrate even more. So this is Polkadot.js, which you might have used if you're in this room. It's probably the most popular wallet, basically way to see what is on the chain. So this is what end users would typically use, maybe not in the future, but right now it is. And the way it works right now, as you see on the screen, is Polkadot.js is connected to a JSON RPC node, to a central access point. And so if this node goes down, this is going to stop working. But we've added to Polkadot.js this light client experimenter. So it was in via Parity mode, because as I explained, the server is owned by Parity. It's basically one server. But we added this light client mode, and if I switch to it, so the loading time is a bit long, and I'm going to cover that in a few seconds. And Murphy's Law. Yeah, okay. So now Polkadot.js is directly connected to validators and full nodes. Like, it establishes direct connections to multiple nodes and verifies all the data that is incoming, verifies all the blocks, verifies through Merkle proofs to be a bit more low level. Every single information that is received is verified cryptographically, if you want. So as you've noticed, the loading time is a bit long, and we are aware of this. And we've also developed a browser extension that is not installed on my machine right now, but I'm installing. This is in French, but you can guess I'm just installing it. So the browser extension, it's taking a bit of time to initialize. I suppose it's checking something. So this browser extension is available for Chrome and Firefox. By the way, please use Firefox. OK, what's happening? It's downloading. OK. Well, Murphy's Law, I suppose. So this extension is basically speeding up the loading time a lot. You will have to trust me on that. I wanted to show it. The extension? Yeah, it should be 3 megabytes or something like that. OK, I'm giving up. So after the extension is installed, so imagine I'm an end user. I install the extension. And after that, Polkadot.js basically loads instantly. You can try it at home. You can try it on your laptop. It's the live Polkadot.js. It's not a tweaked Polkadot.js on my machine. It's the real one that is online. You install the extension, and then everything happens instantly. So you might say, well, Pierre, this was not a very interesting demo. You really just shown things that already work. But that's exactly the point of my demo. I wanted to showcase how using light clients can bring you the exact same user experience as we have nowadays by connecting to a central access point. And that's what's important. Because the reason why this problem hasn't been fixed before is it's quite complicated to bring the same user experience. So the way it works is this project named Substrate Connect. So Substrate Connect is really two things to understand properly. First of all, it's a JavaScript library. So Polkadot.js uses the Substrate Connect JavaScript library in order to connect to nodes. It's very easy to use. Developers, you are encouraged to use it. And secondly, it's the browser extension that I've tried to show. It's fully optional. Everything still works, even if the browser extension is not installed. But the browser extension gives caching and gives way better loading times. And so end users are encouraged to install the extension. And Substrate Connect contains a light client and is in a web page. And that's why I call this the browser-embedded light client. And this is basically a call-out for front-end developers. If you're writing an application, a front-end application that connects to a blockchain, you should use a light client. You should try to use Substrate Connect. Please consider it. It's the same user experience as through a central access point, except better, more robust to hijacking and downtimes. And this is it. This was an introduction to what it is, a light client.
We are not done with Pierre quite yet because I have questions. So Pierre, out of curiosity, is the Polkadot ecosystem already using Substrate Connect?
So we have Substrate Connect has existed for 2 years now. And recently, we've reached out to builder teams, the biggest wallet and front-end building teams, and we've told them, hey, Substrate Connect exists. It's now mature. It's existed for a long time, but it was in development. Now it's mature. Please try using it. And we have a few ongoing projects. Most notably, Talisman are the most advanced, and they're showing a demo, I believe, in this conference. But many other teams are also trying to build on it, and it's just started, and we'll see.
Wonderful. And in addition to wallets, can parachains also connect to a light client?
Yeah, so a light client can connect to a parachain. We've really taken this into account because the use case of Polkadot is not really to connect to Polkadot. I mean, it's cool to connect to Polkadot, but really you want to be connected to parachains. And yeah, so we've really taken this use case into account.
Great. And then could more than one parachain connect to a single light client, or is it one light client per parachain?
No, so this was also an important point. We really envision a future where you are connected, where an end user is connected to, say, 10 different parachains at the same time. And so, of course, we don't want to run 10 different softwares or initialize everything 10 times. One instance of Substrate Connect connects to as many chains as you want, as long as you have enough memory.
Great. And last but not least, you already mentioned this in your talk, but what I would call this central access point problem is actually a problem that every Web3, every blockchain company faces. They all need a solution to this problem, yet do any of them out there have a different solution or a comparable product?
So as far as I know, and I'm actually interested, to give some precisions, the concept of light client is not Polkadot specific. It's nothing new. It's existed for 10 years. And light clients, experimental light clients have been shipped, but actually putting it in a browser and giving the same user experience as connecting to a JSON RPC node. I don't know any other blockchain ecosystem that has done it so far, and if you know one, I'm actually interested to see. But yeah, this was 2 years of effort, and it's not an easy feat, and we're quite happy with that.
Yeah, we all are quite happy with it. Well, thank you so much. This was very exciting stuff. All of you guys out there, regardless of what project you're running, from a wallet to a parachain, definitely start launching your own light clients. And you can go on Polkadot.js today and start playing around with it, even if you're just your average end user. Thank you, Pierre.
Thank you.